Let's see here. There we go. Hello and welcome. We've done some introductions. My name is William Lieurance. We're going to talk about debugging Java apps on Kubernetes. I'm William Lieurance. I do operations work. Will the slides be made available? If you are watching this recording later, here's where the slides are. You are welcome to follow along. You're welcome to look at them later. We're going to talk about Kubernetes and in particular the kubectl, kubecontrol, or kubectl, depending on how you want to say it, interface to the Kubernetes API that lets you do things like run arbitrary commands inside of your containers, copy files back and forth, and then also port forward to allow you to connect up some debugging things. So let's talk about a little bit about the history of debugging Java. Java, it's been around a little bit, and it's got a pretty mature sort of notion of debugging. And there's a lot of different ways that you can do that. A lot of different ways that you can introspect, like what the bytecode is doing, a lot of different ways you can connect that up to source code, a lot of different things that you can look at from an operating system perspective as to what it is that your code is doing. We're going to look at 4 different options over the course of this talk. It is not an exhaustive list, but these are the 4 that have been, in my experience, the most immediately useful for trying to figure out, like, why is my application not working? Why is it running slow? Why is it doing something that I don't want? And those things are heap dumps, being able to attach a local debugger, being able to attach a remote debugger, and then application performance monitoring, which is the industry that is built around doing that doing this kind of debugging and this kind of metrics gathering as a service. Context for this talk, I'm not going to talk about how to install Kubernetes. I'm not going to talk about how to deploy things to Kubernetes. I'm going to assume for purposes of this that there exists some cluster somewhere that is running an application. It's connected up the way that you expect, and that you have access to it, credentialed access in some sort of way. The other thing that I'm not going to go super deep into is just the very beginnings of debugging applications on the JVM. I'm going to assume that you've got like some vague sort of model in your head as to what it is that the Java virtual machine is doing, and kind of like what that direction goes. I'll talk a little bit about each one of those and make sure that we're all speaking the same. I'll have the same sort of object model. I'll have the same sort of nouns together. The last thing is that my examples are running on Java 11 and Kubernetes 1.20, which are a handful of versions behind as of this talk, but there are no important changes as far as the things that I'm going to cover versus what's actually current. So Kubernetes and kubectl or kubectl. I love kubectl. It just sounds so friendly. But so what exactly is going on there? And the answer is that Kubernetes is a container orchestrator, which great. So what does that mean? Okay, so it runs containers, right? It runs Docker containers. It runs Podman is an alternative to Docker. You can run a bunch of different runtimes that do functionally the same thing. You're running Docker containers. And so it'll run them on a particular server. It'll build up a cluster of servers, and it will run a container. It will schedule it on a particular server. It'll schedule the things that container needs that need to be local to it on that same server. It coordinates network access across those containers. It can attach things like additional storage. It can attach load balancers to those containers. And it manages access to all of the commands that allow it to do that. It's got a lovely little API that is accessible over HTTP. You can post and get different YAML documents that describe the thing that you want to exist inside of Kubernetes, like a deployment or a role that your application can take on that gives it access to secrets and to other resources and things like that. The API itself is entirely understandable, but there's a very nice little command line tool that talks to that API for you. It's called kubectl, kubectl. That is a lovely API that can send and receive YAML documents and kind of just do the actual work on the command line. That's what we're going to be looking at mostly. There are alternatives to kubectl. Lens is one, K9s is another. They're basically doing the same thing. They're talking to that API. They are managing the deployments and the load balancers and whatever. They just do it with a slightly different interface, and honestly, one that's a little bit prettier, but is not quite a standard. So kubectl is the one that comes that every piece of documentation assumes that you are running. Every intro will teach you how to use. It's the one that comes effectively built in or bundled with Kubernetes. There are certainly prettier ones. They might be better for other reasons. And I encourage you to kind of like explore the space as far as that goes. There's a lot of work that's been done in making Kubernetes and Kubernetes access better over the course of the last several years. So let's jump in and say, oh, hey, so I've got this Java application running. I've got this JVM thing going on. And let's start. Let's take a heap dump. So what exactly is a heap dump, and what is it that we're going to be doing in this example? And this is like my admittedly kind of like overly simplified version of the memory model of the JVM. You've got in one chunk of memory, you've got meta space and some stuff like the JVM has got to keep like some internals going on. There's something about strings that go on there I'm not super sure about. It's fine. Then you've got the heap, which is where your objects live. And Java is an object-oriented language. So like almost everything that I'm doing in Java lives in the heap. And like, awesome. Okay, so that's where the fun stuff is taking place. That's where the cool things that are my business logic, that's where that's going on. And then you also have some amount of memory that is off heap, that is like C-level structures and buffers. And like, if I'm talking to my graphics card, something's going on over there. And I don't super understand what's going on in there. And so I'm not going to talk about it terribly much. I'm going to focus on the heap. So like we said, like there's a lot of like really cool objects in there, and they do a lot of my business logic. So if I could take like a snapshot of what's going on in that heap, I could get a sense of like what my application is doing at that particular moment and maybe what it's doing wrong. So let's see if we can grab a copy of that heap from a misbehaving application. And how can we do that? Java and the JVM is more than happy to write that big cloud of objects out to disk, serialize, or not even serialize them, but just dump their binary data out to a disk. In order to do that, you need to run a command against the JVM that tells it to do it. Like it's not doing it automatically, or at least not during normal processing. And so we want to be able to run a command against the JVM. But like that JVM is not running on my laptop, it's running on a distant server. And like, I don't really like SSH isn't really a thing anymore. We can't open a shell. I can't get a remote desktop on the server. So how do we do it? And it turns out that the same API that lets me just like view how many Docker containers are running is more than happy to accept a command that says like, dear Kubernetes, please go execute the following command inside of my container and tell me what happens. And that's called kubectl exec, kubectl exec. It creates additional processes alongside the running one. That is only important if you super care about the way that init manages that process later, which for short running applications, for things that are doing like debuggy stuff, you generally don't want it to be running as part of the init system anyway. You don't care whether it, like if it dies, like something shouldn't automatically restart it. So let's do an example. Let's look at running processes and their process IDs. Let's run PS just to see what it is that we can find. The command that we'll be running, kubectl exec, which executes some kind of command inside of your running container. -it is going to make it interactive. There's like subtlety as to what exactly it is that does, but honestly, if you just put like -it, it looks very similar to the Docker command, docker exec -it. -it makes it interactive. Just put it on there, it's fine. The name of the pod that we care about, and then some amount of command. Tell it what it is that we would like. PS is the one that we'll start with. So let's start there, and I think I can do this. Okay. Let's see if this is working. kubectl git pods. So dear Kubernetes, show me which pods are running in my Kubernetes cluster. This kubectl, and let's let's zoom in. No, how about you? There we go. Okay. Okay. Dear Kubernetes, what pods are currently running? What containers are currently running in my cluster? And the answer is, well, I've got this demo that has a leak in it. Like, all right, so just like we were saying, kubectl exec to execute something, -it to make it interactive. Just if you just push it on it, it's fine, and it'll help you out. The name of the pod, which is that. 2 dashes to separate the things that kubectl cares about versus the actual command that you're actually going to run, and the command is ps. So let's see what processes are actually running inside of my container. And that seems to have worked. Kubectl, Kubernetes connected to that pod, connected to that pod, grabbed that container and ran a new process called ps inside of the container, and then shows you the output of that command right here. And we can tell that there's a Java command that's running as PID1, and then there's the actual process list that we had that shows up a little bit later. So that's awesome. We have the ability to run a command inside of our container, even though that container is running in a Kubernetes cluster, 900 miles away from my house. I can just run commands in it and see the results. Super cool. So what can we do with that? That one, is it this one? Nope. Where are we at? Oh, there's my presentation. Okay, so that's awesome. What can we do with it? Well, let's make a heap dump. PS is a great way to start, but let's do something kind of interesting. It's the same beginning of the command. Says dear kubectl, please execute, make it interactive, something inside of this pod. But now the command that we're going to run is we're going to use JCMD, which connects to the local JVM and tells it to run. To do a thing. We'll tell it which JVM to connect to. And we'll say the command that we want you to run is heap dump, gc.heapdump, and we want you to go to, we'll just make a file in the temporary space. Fantastic, let's do that thing. And hopefully this will work. So exactly the same sort of process. We're doing kubectl exec, making it interactive, give it the same name, it's the same one here. And the process and the command that we're running that we just talked about, jcmd, the process ID of the particular Java we care about is 1. It's this one right here. The command that we want it to run is gc.heap dump, and we want it to output to temp/out.hprof. So let's do that. We'll tell it to do that thing. It'll think about it for a moment, and hopefully it'll work. Awesome. And it dumped a heap to /temp/hprof. And that heap dump was created. It looks like it's about 600 meg. It's sizable. It's a lot of space for this application. I'm worried that my application possibly has a leak. So it does that, and that seemed to have worked pretty great. I've made myself a heap dump. The heap dump exists. Very fun. So now what? Hey, we got the file. Well, sort of. That file was created in the container, like the JVM wrote a heap dump to a location in temporary space. And that's great. That would be super duper useful, but like it's still, way over in the Kubernetes cluster, and I need to get it somewhere that's useful to me. In days of old, when the computers were big enough to drop on my toe and make it to where I almost get fired for dropping a server on my toe. It exists in a data center. We could connect that server to a file store or to, I don't know, SharePoint if you're being nutty, or, do something and have it copy that file out. And you can totally do that with Kubernetes. You can tell it to connect up a storage volume that exists on an NFS mount, somewhere that Kubernetes has access to. You can tell the container to copy it to S3 with some number of credentials inside of there. You can get it out in 3 or 4 different ways. But there's an easier way because the thing that actually matters to me is that I have access to this heap dump and I can kind of investigate it and see why is this application taking 600 meg of memory? And the answer is kubectl CP. I want this file on my laptop, right? I want it down here where I can poke at it and I can use my memory analytics tooling and stuff like that, and I can look at it. And the command that I can use for that is kubectl cp. If you're familiar with the general Linux copy, it works very similar. SCP, secure copy, does something very similar where you reference the name of a remote location, : the file that you want, and then wherever you want it to be. And so that's the kind of thing that we're going to use. kubectl is the API CLI client that we're using. CP is the command that says copy a file into or out of a running pod. The name of the pod, colon, the location of the file that we care about, and then wherever it is on our local system that we want that to be. Super cool. So let's do that. We've got this file in temp hprof, so let's pull that down. kubectl cp. This is the name of the pod that we've been playing with, colon, the name of the file we just created, /temp/out.hprof, and I want to copy it to this directory, out.hprof. And I run this command, and it will think about it for a moment because my internet is sort of spotty. So it'll take it a little bit to either successfully or unsuccessfully copy down 600 meg of data. But while that happens, like notice that it's got this like, oh, it's a tar command. Like what's going on there? And the answer is that Kubernetes isn't thinking about the file system directly. All it's doing under the covers, like realistically, is it's running, because it knows how to run commands. It is running a command that says, dear tar, please like create an archive that covers the files that have been requested, and then write them to like write the contents of that archive to the stream of data that I'm used to looking at, the same one that gives us back the stream of data that is the output and the results of any command, like in any command that I run. And then it takes that, like it takes that output and then just redirects it to a file on your local machine. And that's pretty cool. It's a pretty cool sort of like way to use a capability that is very powerful. So being able to run arbitrary commands inside of a container and turn that into some like useful sort of capability, like copying files around, that we normally think of as a different sort of ability, but really is just piggybacking on the same sort of notion of just like we can run things, we can see the output of them. And tar just happens to be a super handy one. So hey, that seems to have worked. And if I look at this directory, out.hprof, LH, yeah, here's got about 600 meg of output, and that's super cool. That's awesome. I've got this I've got this heap dump. So let's take a look at it. Let's take a moment and there we go. And I think Matt is the one that yeah, there you go. And if I start up the old memory analyzer, this is the Eclipse memory analyzer that allows me to take a look at a heap dump and see what sort of objects were in memory. Whenever I out.hprof, that's the one that we just created, that were in memory whenever we created the heap dump. So we can take a look and it'll think about it and parse it, stab at it, and create index files and things like that. It's like, oh, well, yeah, leak suspects. I suspect a leak. And so it finds a bunch of different options, like, oh, here's a problem suspect, and it tells me that, oh, this hello controller is occupying 500 megabytes of memory, and there's one giant concurrent hash map that is causing problems. And I'm like, oh, well, that's probably not great. Out of the 600 meg, 500 meg is in one giant hash map. Well, that tells me that there's probably something going on inside of that hash map. But that at the very least lets me figure out, oh, like this is why my application keeps gaining memory. This is why my application is doing something. Even though maybe the situation where it runs out of memory or the situation where the memory is growing is not one that I can necessarily replicate by running it on my laptop. I can say, this is running in Kubernetes. It is currently in a problem state, and I can download enough debugging information to be able to kind of like analyze, at the very least, let's start with what's going on inside of this hello controller. What's like, which concurrent hash map is it using? And should be able to at the very least, like narrow this down. And there's much more like intricate and interesting things that you can do with the heap dump that are beyond my abilities. But at the very least, this kind of like directs me to the right direction.
Hey, William, real quick, quick question. I don't want to sidetrack the talk too much, but I know heap dumps can sometimes contain sensitive data, when you're in an actual production environment, how do you
Yeah.
handle that? Or I'm assuming like if you're VPN'd in and your laptop's encrypted and you have authority to see that kind of data anyway, because you're in the ops team, do you worry too much about that? Or
I worry about that a lot. I have a slide on this.
Oh, cool. Well, shoot, if you're going to get to it, then I'll.
Oh, no, you have exactly the right question, which is, I don't remember which slide it is that does this. Remote debugging. I talk a little bit about this during remote debugging time. When we talk about like what's like why does JMX not run over SSL? Like what's going on there?
Gotcha.
Yeah, so the answer is being thoughtful. You are entirely correct that the heap dump contains everything that is in memory of that application at the moment that you take the heap dump. That includes like anything that your application is processing that is sensitive, anything that is secret, like passwords will be in there. I work in healthcare, so like there's a lot of like patient information that gets processed by these applications. All of that is something that you should think about. You should be definitely thoughtful about it. Talk to the folks who own that data, whether that's your customers, whether that's a privacy and compliance team at your company, whether that's lawyers. Be aware that like that is like you are going to see like the raw, frequently decrypted, secret information that your application is processing. I can't tell you in this chat as to whether or not it's a good idea to copy it down to your laptop and like be able to walk around with it and like bring it to Starbucks and stuff. You should think about that. You should take care and take some consideration as to what it is that you do with this data. That is absolutely an excellent question to ask, Mark. 100%.
Thanks.
Yeah. Cool. If I go back to presentation mode, click through. Okay, but we got an end-to-end, we got ourselves a heap dump. So now that we talked about getting a heap dump and we saw it work, hey, what can go wrong? Because there's so many delightful ways that this can go wrong. So let's talk about a few of them. Important things to think about. So we ran a big complicated JCMD command. We ran a very simple PS command. And those commands are good and excellent and work very well. But keep in mind that what you're getting access to is not necessarily a shell. So if you try to run something like CD, right, CD won't work because CD implies that you are inside of a shell and you are changing your current context, but that's not an executable somewhere. That's not a thing that you can run outside of Bash or outside of SH or something like that. You can make it work by passing that information to a shell like Bash or like ZSH or Fish or whatever it is that you want to use that is installed inside of your container. But it may not work necessarily just out of the box. Like you might have to wrap it in some shell commands, which is a little bit different than just like seeing a command line on your on your laptop or inside of your terminal. What else can go wrong? Hey, we wrote out 600 megabytes of information to a local disk, and your containers don't always have a lot of local disk. Like not always. Sometimes it does, sometimes it doesn't. If your heap dumps are larger than the available local space, then writing the heap dump out will fail. Like it just doesn't have somewhere to put those bits. And there's a couple ways you can deal with that. One, like the obvious answer is like, oh, just like make the local disk on your container bigger. Tell Kubernetes that it is required to have X amount of available space whenever the application runs, and Kubernetes will make sure that it distributes it to a node that has at least that amount of disk space free. It's totally doable. Other alternatives include attaching external storage, like mounting an NFS volume to some sort of like output directory, and then doing your heap dumps and putting them there. Kubernetes can manage that also. You can tell like, dear Kubernetes, for this deployment, please also attach a volume at this location in my file system. It's able to do that. The amount of free storage, like conceivably, because you're doing a heap dump, the free storage should be a little bit larger than the amount of total memory, because presumably like you're writing out most of the memory to the file system. So a good like easy approximation is like however much memory your container gets, you know, put that much storage plus 10%, you know, on the container if heap dumps are something that you're interested in dealing with. The other thing is that getting files out of a container that is stopped turns out to be surprisingly complex. If you plan on heap dumping like frequently, or if you plan on, for instance, every time that there's a memory error, like tell your application to do that, make it easier on yourself, like do one of these external storage options. Because if it writes, if the JVM writes out a file to the local container and then the container immediately dies after that, it's a lot harder than just that kubectl CP to copy the file out. It's like vaguely possible, but I'm not 1000% sure. Just do yourself a favor and just write it out to something that exists outside of the lifecycle of that container. The NFS mount is a pretty good option. If you do that, copying files, you know, writing files to an external volume, or even just copying them back and forth, file system permissions get weird. The user that's inside of your container might not be the same user that you think it is on the outside. And so like even running something as root inside of your container might not show, like the files might not be owned by root outside of the container. Anyone, like if you've done a lot of like NFS copying back and forth over the course of your life, like all of those caveats will always apply. The access control list and the ownership and whatnot that your storage has might be different than the one that your application thinks about. And so if those models are not exactly in sync, like you'll get weird mismatches, and may or may not be able to read the thing that you just wrote from your container, which is strange. SE Linux access control lists, SE Linux tags can apply as well. The rules for those might be interesting if you're trying to read or write a file later. That's particularly important for NFS. It thinks about that a lot. It also ends up being true for local volumes. Anything that's got a file system that is SE Linux aware, or even like access control list aware, can get confused when files come out of containers. You can spend some time making sure that user mappings for your container are set up properly. There's like, that is an intricate and like very weird dance to try and get that exactly right. Or you can say like, dear storage facility, dear NFS server, please force these files to be readable by me later. And there's some options in there that differ with the NFS storage stuff that you set up. But it's something to think about. Like file system permissions are weird in between the container world and outside the container world. You can also have multiple, like, so the stuff we've been doing with pods, you can actually have more than one container in a pod. The most frequent use case that I've seen for this are either you have a pod that is attached, or you have you have your application container, and then another container that like deals with encryption for some reason that like needs to be like right next to it on the same server, so that it's not trying to do plain text stuff across a network and then encrypt it later. You can have one that injects secrets into it, that is another container running a separate process that talks to, you know, the AWS parameter store, or DynamoDB if you're being not so fancy, or like HashiCorp Vault if you're being real fancy, and like will inject secrets into the names into the container that you care about somewhere. If that happens, Kubernetes is generally pretty good about figuring out like which one the main container is, like which one your application container is, and will default to using that one. You'll notice that I didn't have to specify in any of the example commands that I use, but sometimes that goes wrong. You can specify, you can tell kubectl, like inside of this pod, there are 3 containers, use this one that is the application container to give it some direction, to let it give it some good hints, and tell it the container that you mean when you say, please take a heap dump of this one. We'll talk a little bit more about another use case for those sidecar containers, those containers that talk to other containers right next to each other whenever we get to APM. Oh, there it is. Okay, so let's talk about the next debugging option, and that's JDB. JDB is a Java debugger. It is a very powerful and very complex debugger that's based on some of the C-based debuggers of the past. So you can You can attach to running JVMs and you can run a bunch of commands against them. You can tell them to do a bunch of weird things. You can set breakpoints. You can investigate stacks. You can investigate threads. And it's super interesting and super powerful. And I have like a little bit of understanding of it. It's mostly above my head. But importantly, I want to be able to say like, okay, so like we have these like there's that -it, right? And so we've got that like interactivity. Can I just make a shell? Like, can I just execute like bin bash instead of trying to run one command at a time, like that J command and PS and whatnot? Can I just like get into my container and just like screw around in there? And the answer is totally. JDB is a great example of doing that. So let's look at what that does. What are we actually talking about here? So we ran PS and we ran J command, and those were individual commands that we passed to our container, and we ran them and then we looked at their output, and that's great. We can tell Kubernetes to set up a TTY, a teletype, a keyboard and monitor effectively, that are able to talk to that container. And like, that is the thing that runs, is like a shell that can like accept commands and execute them and show them your output. And that means that even things like Vim can work. Like you can run text editors. You can package things into your containers that allow you to introspect it and like play around in there. You can install things. You can run your apt-get or your DNF or yum or whatever, and install different packages if you really want to. Anything at the OS level that you want to package in there, that can be useful too. If you take this to its logical conclusion, you could run your entire IDE, your entire development environment inside of the container that is also running the application, and like effectively log into that container and run all of the different like intense stuff to see what it is that application is doing. I'll say don't do that. I'll show you a better way to do it here in a little bit. But like you can, a better thing to do is these relatively simple, directly kind of like text interactive commands like Vim and JDB that we'll take a look at. Those make a little bit more sense to me. They're the lag on some of this, some of the IDE stuff can get a little intense. So let's take a look at what that does. So how can I get a shell? Let's look at those pods again. Let's see what sort of shell can I lie. So the command that we're running, kubectl, exec it, same one that we've been running this entire time. Here's the name of this this pod that I actually want to run stuff in. And this time the command that I'm going to pass it is a shell, is bin sh. And I'm going to see if it is capable of running this shell and attaching. This is not just the output, this is now interactive. The IT helps with that, but this shell is accepting input and showing output. This is my container. Like I've got a shell inside of the container, and I can do basically whatever I want. I can look around in here. I can run that same PS command that we had before, and now we can see that like one of the commands that's running is this shell, and then my process list, and then it's the same Java. It's the same web application that we've been poking at this entire time. So if I look at that Java command and I see like what are all of the arguments that are passed to it, I've turned on remote debugging. So it's got JMX, which we'll take a look at here in a little bit. And importantly, it's got this JDWP, the Java Debug Wire Protocol, turned on. And that means that I can just connect up JDB on port 6000 and poke around and just like see what my application is up to. And because I'm inside of a shell, I can do that directly. So this is a shell that's running JDB. It's running inside of that container. So all of the commands are local to it. And I can say just attach to port 6000. And it thinks about it for a second. It's like, oh, hey, here's your debug. And I can take a look. Here's just a list of threads. Here's all the threads that are running. We've got our Hazelcast clustery things for my application container. I'm running Payara as my application stack. So it comes packaged with Hazelcast. It's got, here's some of the other ones somewhere in here. Here's my default worker threads and other such things. Somewhere around here, there's an HTTP listener thread that I'm sure I'm just not seeing. Oh, HTTP listener. Yeah, right there. So this is all the threads that are going on. And this JDB, like there's a bunch of crazy things that I can do in here that, fiddle with the class path, set breakpoints, like modify things. You can like introspect classes, all of the stuff that you would normally do through like your IDE's debugger, you can do by hand through JDB if you really want to. Importantly also though, you can like play around inside the operating system. So you can see like, here's what's actually going on inside of that container and take a look at that, which is pretty helpful. So we normally talk about like, oh, so that worked out really well. So what are the ways that this can go wrong? One of the easy ways, you'll notice I use bin sh. If I try to run bin bash, because folks generally like bash instead of old school sh. But if I try to run bin bash, it gives me this like absolutely horrifying OCI runtime exec failed. It gives me a go line with a stack. It's like it is horrifying. But the only part that is actually going on here is that no such file or directory. Like bin bash is literally not installed in the container. Like that's all this means. It is a huge and horrifying and terrifying error message that to just tell you that like there's no such thing as bash on this container. It's just not installed. And that's all that is. I've discovered, especially like as it's very hip to make your container as small as possible to make it start up faster and have require less disk space and things like that. Folks remove things like bash, things like CSH, a bunch of the more popular shells, but they'll usually leave sh as an option. That's usually what happens, and that's fine. Like it is a big scary message, but like honestly, this just means that like bash just isn't installed. The other thing that can happen that you'll see every once in a while, and it happens to me frequently enough, probably once every handful of months, is that you'll run a command. Frequently, you'll have like copied up an application like I need PG dump for some reason. I need to connect up Postgres. I need a Postgres client, something like that. And you'll upload it, and then you'll try to run it. And it'll tell you that like it's not found, even though like very obviously like the command is right there. Like it's just right there. And what this ends up being is it is very popular to run a kind of container called Alpine. And Alpine is a container that amongst the different ways that it shrinks down the amount of space that it requires is instead of running the normal copy of the GNU project's libc, the things are compiled against, it'll run against like a micro C or some other user space to do its C libraries. When that happens, if you copy up a command that is compiled against one tool chain and try to run it in a container with a user space that exists in the other one, not found is what you get. And the thing that it's actually not finding is it's not finding glibc. It's not finding some of the C libraries that are attached to it, but that is very not obvious. And it happens frequently enough to where like you'll look at it and be like, this is bananas, like what in the world is going on? But like not found can mean that. And it, like I said, it happens often enough to where I generally like to talk about it. You can fix it by making sure that you're using the same user space. So if you are using Alpine, like be sure that your like helper applications that you're uploading and installing and things like that are also compiled for that same space. Or honestly, don't use Alpine. Like if this is something that you're doing frequently enough, like just make it easier on yourself and don't use the super slim, like super shrunk down container. If you're trying to do a bunch of debugging inside of the container application, you're just making it harder on yourself. So we got that GDB, and that GDB was really cool, but like, man, that's complicated. But at the same time, like JDB is just debugging by attaching to a port. And like that feels pretty cool. And like, if we can attach to a port inside the container, and like Kubernetes knows things about ports and it knows things about networks, like what about like letting my laptop connect to it? And it turns out that's possible too. There are two major ways that I know of that I've seen recently for doing kind of remote debugging stuff. There are two kind of protocols and two different like ways of doing it. One of them is JMX, the Java management extensions. There's an API for pulling metrics, for pulling runtime, doing simple commands, doing things with like looking at certain objects and getting some internals of the JVM that are kind of cool that you can connect up and see. And then the other one is just like straight up debug wire protocol. It's a little bit newer, but it is designed for allowing remote debugging of applications that are running to happen inside of an IDE that already has a copy of the source code. So we'll take a quick look at both of those. And yeah, like now we're talking, like we're off to some good times. You have to turn on JMX. It's not turned on by default, which is probably pretty smart. You got port 5000 is the default. You have to set up both JMX and RMI, the remote management interface. You can run them on the same port, confusingly. Excuse me. And you have to say that you want it non-local and deal with some authentication. And like, wait a minute, authentication false, SSL false, like that. Hey, now, that's probably not super right. And this is kind of what we talked about a moment ago, where like, I can't tell you whether or not doing unauthenticated debugging on your production applications is a good idea. The fact that we're stopping and talking about it indicates it's probably not a great idea. And so like, be thoughtful, like find a friend, talk through like what are your risk models, what can go wrong, what can go right, what compensating controls can you have on it, stuff like that. Like find something that works for you and for your use case. Like I can't tell you to do it. I can't tell you not to do it. Think about it. And like, again, find a friend. If you do decide to go ahead and turn that on, here's a great command: kubectl port forward. And port forward does more or less like you might think, which is like, hey, I want to pretend that this port on like in this this port in this container is actually running on my local machine. Please make that happen, and kubectl will do that. We're going to run the kubectl port forward command, give it the name of pod, and tell it a couple of ports that we want to forward. Each time, the first one is the one that I want on my laptop. The second one is the one that I want reflected in the container. In this example, we'll be using 5000 for RMI or for JMX and 6000 for remote debugging. So we can do that. And like what happens when that occurs is that now you've got like network ports on your local laptop. You can use your own IDE. You can use like the stuff that is running on your laptop to like talk to that JVM. That way you don't have to package everything inside of the container. You don't have to package IntelliJ inside the container. You don't have to package Eclipse or NetBeans or whatever, or even like Vim and like JDB, which is all really, really powerful. It lets you have like a really complex and interesting tool, like toolkit on your machine, on your local laptop, but you don't have to like have that installed in production, but you can still like do a bunch of the same debugging stuff that you're used to. So let's take a look at that. Let's see here. Here's this same container that we've been looking at for a while. And let's run the command that we just talked about, kubectl port forward. And I want this pod. And we talked about port 5000 for JMX. I want that to be 5000 on my laptop, and 6000 for JDWP. I want that to be 6000 on my laptop. Neat. And so that'll run for a moment, and it'll think about it and say, oh, okay, cool. We've got IPv4, IPv6. Everybody's really happy. It says forwarding. And it'll sit here and it will forward for as long as this command is still up and running. So like, how do we take advantage of that? Well, just like we had over here in Matt, let's talk about Visual VM. Visual VM is an application that comes that used to be expensive from Oracle, and I think now comes packaged with JMX or with the JVM. But there's a couple, 2 or 3 of these. JControl is another one. But I want to run Visual VM, and I want to run that open JMX, like dear Visual VM, please attach to JMX on localhost port 5000, the one that is on my local laptop, port 5000, the one that is being forwarded off to the container. So let's see if this will actually work. Hopefully it does. Yay for live demos. Okay, something already exists. Remote, is this us? Reload. PID number 1, yeah, this is us. So it is considered local because it's on localhost, but this is the one, PID number 1. This is the same thing that was going on that is actually running in my container, which is pretty cool. So I can see this, the name of the Java, things like that, system properties. If you see any super secret passwords or something, please ignore them. There aren't any. It's fine. Yeah, and I can, here's, we were looking at threads earlier. Here's all those threads. And importantly, like, because this is live, because this is actually like connected over the network, it'll show me like which of those threads are actually doing something. And the answer is, oh, here's your Hazelcast stuff. Here's your, your HTTP connections and stuff like that. Things that are, I'm sorry, HTTP is not actually running, so there's nothing that's attached to, there's nothing that's reading or writing from that application right now. Yeah, and you can kind of see like here's the stuff, like what is my application busy doing? And you can take a look at that. You can take a look at, here is the size of the heap. It's 600 and slowly growing over time. Well, that's probably not great. But we also have a little bit of garbage collection, and that's awesome. You can see how many threads there are, CPU usage, garbage collection activity, all sorts of really, really cool stuff. You can sample, being able to sample like what is the CPU doing. This is a little bit more interesting than just looking at the thread page, because it actually like will get deeper into like what classes are actually being run, like where is it actually spending time inside of, it's all largely inside of Hazelcast in this example. But like the important part here is that like this is a running application in a Kubernetes cluster that I am able to investigate and I'm able to dig into by connecting over the network to it and looking and seeing what it does. And all of that is like all of the port forwarding and all of the like network connectivity stuff is all built into Kubernetes and comes with it just out of the box, just like for free. And that's pretty cool. We also did port 6000. So is there something even more interesting that I can do than just connecting up and seeing some metrics? Is there something that I can do with my IDE here? I have this is the source code for this website that I've created, where I have a bunch of users and whatnot. And it turns out I can attach a debugger. And this debugger is the local debugger thing, and it runs on socket attached. So my IDE knows how to connect to connect over the network to an application, to a JVM that's running using this standard protocol. And I tell it that I want something on localhost, I want something on port 6000, and I say yes, please go do that thing. And it thinks about it for a minute. There's a little bit of lag as it kind of negotiates what's going on and gets the first list. Here's all the same threads that we were looking at before. And after thinking about it for a moment, okay, cool, it's good to go. And it's watching all of those same threads. It's doing all those same things. And importantly, I can do stuff like in production, add a breakpoint to an application such that, if somebody hits this, the website will stop and it will let me see what's going on, which is, again, in production, maybe not the best idea, but in your integration test environments and your unit test environments that might be running in Kubernetes elsewhere, like this is a good and perfectly valid like way to do things. But yeah, I can run a breakpoint right here. And then if I go and say, like, please run this application, it'll connect up. I'm attaching to that hello container that hello controller that was having problems earlier. And I look and it's hit. I got it. The thread the thread that executed this code was this HTTP listener. It opens up, here are all of the variables that are happening. Here's everything that's in scope that current users turns out already has, huge numbers of users. And I can do more investigation. I can figure out like why, here's that concurrent hash map. Like this is probably the problem that I was seeing in my heap dump earlier. And I can do more investigation. Like, why is this user, in here? Like what, this should be a set. Like, why is this not deduplicating? Like, why does the set only ever expand? And I can investigate and figure out turns out super easy. I screwed up my equals. My equals override is bad. but yeah, you can do this sort of investigation. You can have your IDE connect to an application that is running in Kubernetes, in a Kubernetes cluster elsewhere, using only the tooling that kind of comes with your IDE and comes with Kubernetes. And this to me is like maybe the most powerful thing, right? It's like being able, because like there are a handful of conditions that you will see in applications that are running not on your laptop that you won't off the top of your head be able to duplicate because you honestly don't know what's going on. And so being able to connect to a running application that has a problem and being able to inspect it and being able to analyze it is, in my mind, like the most powerful use case that this discussion about Kubernetes enables. And this to me is the really, really cool part. So yeah. NetBeans is cool. So what can go wrong? There's a couple, I know there's always some things that can go wrong. You can't run this twice with the same ports, right? So like if you try to connect to two different applications, they can't both be on port 6000 because then like you try to connect your debugger and it's like, I don't know which one you wanted me to debug. So give yourself two different ports, two different local ports. It'll definitely work with the debug wire protocol. JMX has like a lot of feelings about port numbers and about knowing what port numbers are. So that may or may not work, but the debug wire protocol totally does. It figures things out pretty well. JMX is still really hard. It is an older piece of technology that has a lot of feelings, like I said, about like, it really wants to know that the host name is identical between the container and your laptop, which in a world of like ephemeral stuff and like load balancers and things like isn't necessarily the case. And it gets hard. The word, if you just use the word localhost, it tends to work most of the time for JMX stuff. That can break other things. That can break APM, that can break like your Datadog metrics gathering can get confused if everything's called localhost. But it does make JMX work a little bit better. JMX and RMI are two different protocols that can speak on the same port. You have to remember to do both of them. Basically, JMX is a protocol that was constructed before a lot of our modern conventions on protocols and ports and things were kind of standardized. So it's just a little bit weird to think about. The next kind of direction to go with this is like, oh, so we can set up arbitrary ports locally that can like link up into Kubernetes. And that gives us like a lot of different options. And like, I can run things that aren't just my one IDE. I could also run like a different application that can talk to other microservices inside of the cluster. And that's really cool because that means that I can develop on one microservice locally, but I don't have to run the whole stack on my laptop. That's really cool. There's some ways to do that. There's a project called Telepresence, which is an open source foundation-backed application that does basically that same thing. IntelliJ IDEA has a lot of bindings into it. It's a good piece of software. I haven't used it very much, and like I haven't used it enough to be able to recommend for or against it. But like squinting at it, like it looks like the right idea. It looks like kind of the next direction to go. Is like being able to say that the Kubernetes cluster ends up being kind of an extension of your laptop at that point, and like makes it to where you can do inordinately complex like microservice-y, database plus Elasticsearch plus 50 other applications that you need without having to run them all on your single laptop. The last conversation that I want to have, and this shouldn't take terribly long, is a discussion about like, so what is the next kind of like other way that I can make this better for myself? And that is application performance monitoring. And so like we have over the course of the last hour, like done individual debuggy things, like logged into a container and like poked at it and looked at metrics from JMX and looked at like debug things. But we did that kind of ad hoc. We did like, I'm a human being, like typing on a computer. And like, that's the beginnings of wisdom. But like, gosh, what if we could get a robot to like sit and just like watch the application for a while and keep track of those really cool metrics and like look at the debug traces and look at those over time and tell me like what's going on there. And the answer is that like that exists as an industry, application performance monitoring. There's generally two parts to it. There's a client library that will do the debugging and the watching and will run alongside your container and like debug your app and just like tell it to heap dump every once in a while or tell it to do a thread dump every once in a while. And then send the information about that off to a remote server. That is the second part that receives the information, parses it, indexes it, makes it pretty, looks at the data, gives you recommendations. There's some companies that will like rub some AI on it that'll tell you like, oh, this is where your application's having problems, things like that. There's a lot of options. There's a whole industry behind it. It's actually really cool. We talked a little bit about what a sidecar container is, and in this conversation, we've talked about like the idea of pods that exist as a series of containers that need to be on the same server that talk amongst themselves to accomplish like one application's existence. APM takes advantage of that. Just like like injecting secrets out of Vault or encrypting traffic over a network mesh or something like that. A sidecar container like spins up for the same life cycle as your application and helps it do something that you didn't want to build into the container for whatever reason. Usually that answer is versioning. We talked about a couple of examples, and then the one that is pretty common and pretty handy is another container that can sit and connect to that port 6000 on your JVM and like download the data, download the debug stuff, and then be able to ship it off and like get it parsed and get it thought about. Importantly, it's versionable and it's managed separately. So like it's not part of your build process at that point. It's part of your deployment process. It's part of running inside of Kubernetes, but does not impact the way that your application is built, or you don't have to put it inside of Jenkins and things like that. There's some lovely screenshots. You get these nice little burn down diagrams of like what your classes are doing. Here's the time that they take, and there's bar graphs, and it's all very pretty and very compelling. It is still an evolving industry. There are still changes that are going on. You'll get a little bit of a performance hit because now your application is doing something that isn't like the normal business logic. And so like doing thread dumps, like it takes time. Doing memory dumps takes longer. Apache Skywalking, which is an open source implementation of this, claims about 10% of CPU is about right, and adds a couple of nanoseconds of latency. Or tens of nanoseconds of latency realistically. So like it's probably, maybe it's something you want to turn on in production. If 10% CPU feels like a lot, then like be thoughtful about whether or not you turn it on all of your systems, or like if there's a button you can flip somewhere. If nanoseconds of latency are important to you, probably don't leave it turned on in production. You can get occasional weird bugs because like anytime that you're like digging around inside of the internals, like stuff can get weird. Like anytime that you're like reading like class structures and like doing reflection things, like there's the possibility of running into some weird bugs. And you'll get weird like access control things with the security manager that's now being stripped out of Java 17. And there's some weirdness in it. It's also like thread dumps are easier and easier to sample just because they're so much quicker to run. Heap dumps are still kind of like hard to parse and like harder to think through, but it's getting better. So if your application is like CPU bound and you don't know why it's consuming 1000% CPU, that is easier to diagnose than why is my application leaking memory using APM is basically the long and short of that. But that's everything that I wanted to talk about, and we have been talking for almost exactly an hour. I am more than happy to hang out, to chat more. There's my Twitter tweets. There's an email address. There's a website at williamliurance.com. I am always happy to talk about this sort of stuff. I'm always happy to talk about ops, to talk about DevOps, to talk about dev, to talk about Java. Like this stuff is really, really fun to me. And I'm super excited to talk more about it. Are the slides available? They are available, and there they are. I will zoom out a little bit. If folks have questions, if folks have chat, if folks have other things that they want to talk about, yeah, we can talk about Kubernetes, we can talk about Java, we can talk about whatever you want. We can talk about Oklahoma football, we can talk about, yeah, basically anything. That is everything I've got.
I don't want to stop the recording until we captured any questions, just in case they're useful for other people that watch it.
Totally.
This has been very helpful and very informative, William. Thank you so much.
I'm glad. Thanks for that. I appreciate it.
Yeah. Especially timing has been really good for us, for me especially.
Oh, good, good, good.
Thank you very much.
Yay.
All right, I'm gonna stop the recording. I do have a question, but it's not.